Hello, my name is Sung. So today I will talk about logistic regression. These are contents of today's topic. I'll start with the background, explaining why the linear regression does work for classification. Then I will go over how to derive logistic function and how to estimate parameter, and briefly discuss how to make predictions. Or we will extend multiple predators and multiple classes with multiple logistic regression and multinomial logistic regression. And next, I will explain one example problem from ISLP textbook, and finally summarize today's content and end the presentation. So there is two main reasons. First, wider range of results. Linear regression covers all real values, but we need to constrain the prediction to 0 to 1. And second is the linear regression is nonsensical because linear regression produces meaningless intermediate predictions. So let's see more details. There is two graph. This graph shows the difference between linear regression and logistic regression. So for this linear regression case, there is a value below the 0, so this is not suitable. And for the right side, in this case, the linear regression produce strange predictions like drug overdose is an intermediate reaction between stroke and epileptic seizure. But in reality, that prediction is meaningless because there is no relation between those classes. So we want to limit the prediction 0 to 1, but also we want the prediction have a linear relation because that is very good and a good relation for the predictions. So to solve these problems, so we will introduce two main concepts, odds and logit. But logit is log odds, so odds is very important. Odds represents the ratio of the probability between events occurs and not occur. So for example, if events occur 80%, its odds gonna be 4, like this. And then let's derivate the linear logistic function with these things. So logit can cover the all real values. So we can assume that logit can cover all real value, and we can assume the logit has linear relation with beta 0 plus beta 1x. So if we can simplify this equation as px equal to something, then px is value between 0 and 1. So px can have value 0 and 1 and linear relation. So it has everything we need. So let's simplify this equation with takeoff log with exponential, then px over 1 minus px equal to exponential beta 0 plus beta 1x, and px gonna be exponential beta 0 plus beta 1x over 1 plus exponential beta 0 plus beta 1x. So this is linear function, and we have to estimate the coefficient beta 1 and beta 1 and beta 0. So let's talk about how to estimate the coefficient. Then gonna be use maximum likelihood. In linear regression, we use the least squares and minimize the squared errors. But that was actually on maximum likely estimation approach under the normal distribution. So in logistic regression, we use the same idea, with maximum likelihood estimation, but we have to choose coefficients that maximize the likelihood of the observed data and find parameters that make the data most probable. After we find coefficients of each parameter, then we can predict probability of the class from the parameters. So let's make predictions. In making prediction parts is similar with linear regression. There is jet statistic which have same meaning and same role with t statistic in linear regressions. So consider about these two, student and balance. Beta 1 hat gonna be 0.4049. Beta 1 hat gonna be 0.0055. Then jet statistic and p-value is 3.52, 24.9, 0.0004, under 0.0001. Then these two predictors has appropriate values. We can say and bell appears to be more likely to divert, because divert is the class of this case. So we can say student imbalance appears to be more likely to divert. But it seems very logical, but in reality, there is few single logistic regression in reality. So we have to consider the multiple predictors. So when we take this case to the multiple logistic regression, there is some confounding. So let's see the student part. There is negative coefficients. Before this case, the coefficient of student was positive, but so the most interesting change happens with the student variable, because in the single logistic of likely to differ, but the controlling with balance and income, the coefficient turns negative. So this means students are actually less likely to divert. So in other words, the earlier positive relationship was caused by confounding, and students tend to have higher balance, which increase their deferred probability in the model. But this clearly shows that after controlling for balance and income, students are less likely to divert. So this case clearly demonstrates how multiple logistic regression helps us to uncover the true relationship between variables by eliminating misleading effects like effects caused by compounding. And so far, we've seen logistic regression handle two class problems like divert or not divert. But when Y has more than two categories such as drug overdose, epileptic seizure, then the binary logistic model is no longer enough. To solve this, we use softmax function, which generalize the logistic regression to multiple classes. Then I will show the softmax function. This is the softmax function, and each class has its own linear function, and the softmax normalize them so that all probabilities are positive and sum to 1. So if you sum the all probabilities, then we can take sigma with k, then it's gonna be like this. So it's gonna be right. So it easily proved. So this is Mutinomial logistic regression. In Mutinomial logistic regression, softmax function would be work, and it is always more because we use exponential, and its sum's gonna be 1, or probability sum gonna be 1. So the problem with these concepts, the problem, number one problem is, this problem is ISLP chapter 4 exercise 12, and for the A is the log of orange versus apple in your model. So my model is here, and my friend's model is here. So my friends use soft max formulation, and I use the single logistic regression. Let's take my logos then. Px was 1 plus exponential beta 0 hat plus beta 1 hat x exponential beta 0 hat plus beta 1 x. Then logos is gonna be 1 minus px. Px log. It's gonna be log 1 minus 1 plus exponential beta 0 hat plus beta 1 hat x exponential beta 0 plus beta 1 hat x. And then it's gonna be like this. So multiplying the 1 plus exponential beta 0 hat plus beta 0 1x for the both sides, then log 1 and exponential beta 0 hat plus beta x, then equal to gonna be beta 0 hat plus beta 1x. We can easily think with the concept of both here. So easy to think beta 0 plus beta 1x, but I showed why in this case original my regression model gonna be 0 hat plus 1x. Answer is gonna be beta 0 hat plus beta 1 0, beta 1 hat x. So that the question, why was the orange versus apple in your friend's model? Oh, my friend's model equation is like this. So it's gonna be 1 minus exponential upper hat orange 0 plus upper hat orange 1 x. Oh, sorry. Exponential alpha hat orange 0 plus alpha hat orange 1x plus exponential alpha 0 plus alpha 1 x like this. Like this. So, oh, this is, oh, sorry. 1 minus, then this is gonna be logic. Then we will multiplying this side gonna this size, and then exponential apple 0 plus apple 1x log exponential apple orange 0 plus apple orange 1x. It's gonna be orange 0 minus apple 0 plus alpha orange 1 minus alpha orange apple 1 x. This is the answer. And next, hold that in your model. Beta 0 is 2 is minus 1. You can think this equation here, then alpha orange 0 minus alpha apple 1 is alpha apple 0 equal to beta 0 hat, and alpha orange 1 hat alpha apple 1 hat is beta 1. So this is 2 and this is 1. So to reduce the redundancy of this softmax formulation, we can set these two things 0. Then alpha orange 0 gonna be 2 and alpha apple 0 gonna be 0. Alpha orange 1 gonna be minus 1. Alpha hat apple gonna be 0. So this is the next one. As the alpha 0 is 3 and alpha 0 is 1 is 0.6. So here we choose the 2 and minus. So we think the how to solve this problem then. Upper orange Alpha 0 is 3.
So
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 so I think there's alpha 0 is 3 and alpha 1 is 0.6. So alpha orange beta 0 gonna be alpha orange 0 minus alpha apple 0. Same case. So alpha orange 1 minus alpha apple 1. So but there is nothing about orange, so I will set orange and orange 0 and orange 1 as before the case 2 and minus 1. So it's gonna be 2 minus 3 and gonna be minus 1 minus 1.6. So it's gonna be minus 1 and minus 1.6. This is the answer. So then there is the last question. Finally, suppose that you apply both models, then how can we talk about this? As we use the same information with alpha 1 0 and minus alpha apple 0 gonna be beta 0 and alpha orange 1 and alpha apple 1 gonna be same with beta 1 hat. So I think that we can consider these two equations agree every time because two models are equivalent. They just choose different coding of the same underlying logistic regression. So this means softmax function with equal to then equivalent to the general. So this is our problem solving. Then I will talk about summary. Classification in logistic regression, two limit of linear regression. We talk about two linear regression, so range and meaningless prediction. And when we derivate the equation odds and logit and most likelihood estimation to estimate parameter, and there is confounding when we moves to single to multiple logistic regression, and softmax function which was used in multinomial logistic regression. So you have to remember these 5 key concepts. So thank you for hearing this presentation.